So, you know the log rules. Now let's learn how to solve equations with them. Starting with this one. Given that log base 3 of x plus 1 is equal to 1 plus 2 log 3 x minus 1, show that 3x squared minus 7x plus 2 is equal to 0. Well, first thing that I'm going to do is I'm going to put all the logs on one side just to make things easier. So, log x plus 1, base 3, plus 2 log 3 of x minus 1. Sorry, it should be a minus. Change that. Thank you. And that's all equal to 1. Okay? So, there's another rule that we can use, but in order to do that, the coefficients need to be the same. Here it's 2. How can we get rid of that 2? Well, we can put it into the log. So this is log base 3 of x plus 1 minus log base 3 of x minus 1 all squared. Alright? And that's all equal to 1. Okay? So now we can make it all into one log, where this is log base 3 of x plus 1 over x minus 1 all squared, and it's equal to 1. Now, I know what you're thinking. Sammy, how am I going to take it out of the logs? Well, remember what I said, guys. This is the power needed of 3 to get it equal to 1. So what we can do is we can power both of these by 3. And what I mean is that 3 to the power of log 3 x plus 1 over x minus 1 all squared. Minus 1 all squared. Right? That's equal to 3 to the 1. Now, because we're powering a log, right? And it has the same base, the logs will cancel out. So that's the same as x plus 1 over x squared minus 1 all squared. Sorry, x plus 1 all squared. And that's all equal to 3. And then from here, it's a simple rearrangement, whereby 3 times x minus 1 all squared is equal to x plus 1. Let's expand the bracket. So that's 3 times x squared plus 6x minus 6x plus 3 minus x minus 1, because we want to make it all equal to 0. And you should get your answer of 3x squared minus 7x plus 2 is equal to 0. Okay, so all we did was manipulate the log rules and the fundamentals of how logs work. Now to solve this, all we need to do is plug it into our calculators. So x is going to be, and I'm going to use my nice shiny Class Whiz calculator. I know some of you have graphical calculators. You do not need to flex on me. And I get an answer of 2 and a third. And those are your final answers. Is this video helpful? Well, make sure you subscribe so you never miss a video like it from me. Now let's take a look at this one. Sketch a graph y equals 4 to the x, stating the coordinates of anywhere where the graph crosses the axis. So, first let's draw a set of axes. This is y, this is x, and this is 0. Okay? Remember what we said that exponential graphs look like? They look something like that. Yeah? Where will it touch the x-axis? Well, X is 0 here, and 4 to the power of 0 is just 1. Furthermore, where is it never going to touch? It's never going to touch where y is equal to 0. Okay? Now, how would we solve equation 4 to the power of 2x minus 10 to the power of times 4 to the power of x plus 16 is equal to 0? Well, let's write that down. So 4 to the 2x minus 10 times 4x plus 16 is equal to 0. Notice what we have here. We have a 2, we have a 1, and we have a non-x term. What does that look like to you guys? Exactly. It looks like a quadratic. Yeah? If you ever have this as double this, and in a third term that's nothing, that's a quadratic. So what we can do is we can say that 4 to the power of x, is equal to minus b plus minus square root of b squared minus 4ac over 2a. And if we plug that into our calculators, we get 4 to the x as, right, where, just probably should mention this, a is 1, b is minus 10, c is 16. So 4 to the x is equal to either 8 or 2. And now we can just use the log rules. So 4 to the power of x is equal to 8. And so what we can do is take the logs on both sides. So log 4 to the x is equal to log 8, all right? Doesn't matter what your bases are. Does not matter in the slightest. Because we're going to take x down. So x times log 4 is equal to log 8. And so x equals log 8, over log 4. Which if you plug into your calculator, you should get an answer of 3 over 2. Okay? And same here with the second solution. Okay, my PowerPoint is bugs. It's fine. 4 to the power of x is equal to 2, which means log 4 to the x is equal to log 2. And so x is equal to log 2 over log 4, which is equal to a half. I know you could say, oh, but this is obviously just the square root, so of course it's a half. I know, but this is a skill which will translate nicely into the next example. But if that doesn't make sense to you, then join my Discord server and ask me whatever questions you want down below. Now let's look at this example, right? As I was saying, solve the following equations. For this example, we can't use common sense, so to speak, right? We have to take the logs. So let's look at the first example. 3 to the power of x plus 5 is equal to 6 to the power of x, right? The first thing we can do is find the logs of both sides. So the log of 3 to the power of x plus 5 is equal to the log of 6 to the power of x. Yeah? That's just another way of solving an equation by performing a function on both sides. Now we can use our log rules to bring both of these down. Yeah? So this is the same as x plus 5 times log 3 is equal to x times log 6. And so what we can do is make x the subject, because that's what we're looking for. x log 3 plus 5 log 3 is equal to x log 6. So what we're going to do is swap it around. So this is going to go on that side. That is going to go on this side. So x times log 3 minus x times log 6 is equal to 5 log 3. And so we factorize. And so therefore x is going to be 5 log 3 over log 3. Oh my goodness. I'm going to write it again. Is equal to 5 log 3 over log 3 minus log 6. Which, if you plug it into your calculator and you use any logarithmic base that you want, it can be 3, it can be 6, it can be affinity, I don't care. You should get an answer of minus 7.9248. Yeah? And now let's try the other example. 7 to the power of x plus 1 is equal to 3 to the power of x plus 2. Let's take the logs on both sides. So, log 7 x plus 1 is equal to log of 3x, 3 to the power of x plus 2, excuse me. And again, let's take the logs and bring them to the front. So therefore, x plus 1 log 7. Right? Actually, other way, sorry. Is equal to x plus 2 times log 3. Now let's expand the bracket. So, x log 7 plus log 7 is equal to x log 3 plus 2 log 3. Let's make all the x's on one side. So x log 7 minus x log 3 is equal to 2 log 3 minus log 7, alright? Now let's factorize. So this is x times log 7 minus log 3, which is equal to that. 2 log 3 minus log 7. And so x is equal to 2 log 3 minus log 7 all over log 7 minus log 3. And it doesn't matter what base you use. As I mentioned before, you should still get an answer of, if I've plugged this into my calculator correctly, 0.2966. And those are your final answers. Thank you guys for watching. I hope this video was useful. If you guys want to pass your exams with flying colours, you can get tutored by me. Drop me an email for a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.